In our dance imitation experiment, we have a more complex grammar representation with higher dimensional input data. Using an 8-camera motion capture system, the angular displacements of 18 human joints are obtained, resulting in 54-dimensional input data. Motion primitives are basic action units, such as the reaching forward of the right arm in this example. Temporally segmented input data are represented as histograms using a bag of words approach, which are then clustered into groups with the same number of symbols. Using clustered histograms as input, we train nonlinear support vector machines. Using the trained support vector machines, input data are converted into probabilistic symbols and activity grammars are learned. We now show some testing examples of 3 types of dances composed of longer sequences of motion primitives. In this test, the human rotates their left and right arms for 4 times in alternating order, followed by turning the head left and right the same number of times. Here you can see when the parsing has failed and wrong symbols are executed using the baseline method. Incorrectly parsed symbols are marked in red color. In this case, however, the input errors are handled correctly using our method. In this test, the human starts by reaching the right arm forward 4 times, then stretching both arms forward, followed by reaching the left arm forward 4 times. Please note that the robot's trajectories are learned directly from the human joint data. This is achieved by mapping the human's joint space into the robot's joint space and then generalizing from all trajectories of the same motion primitives. We use a position controller to execute generalized trajectories, which are a time series of joint positions. In this test, the human stretches out the left arm, then the right arm, and then turns the head to the left. This sequence is repeated 4 times. Again, the robot is not merely imitating human movements. It is using contextual knowledge acquired in the training stage to correct ambiguous or wrong actions.